In this video, we're going to look at the proof of Theorem 2. This theorem says the angle which an arc subtends at the center of a circle is twice the angle it subtends at any point on the circle. So what it means is this angle here is going to be twice that angle there. So that's what we're trying to prove. Okay, just take those out. That's our proof. So we can't assume it to be true. That must be our conclusion at the end of the proof. All right, so what we're given and what you'd be given in a picture in a test or an exam is that you've got the circle and it has center O. And in this case, you're given C on the circumference. And what you are required to prove is that angle AOB, that angle at the center, is equal to 2 times angle ACB, the angle at the circumference or the angle touching the circle. Right, so let's see how that proof would look. As with many of our proofs, we need to start with a construction. So we're going to construct radius CO. So let me do that with a dotted line here. Let's move. There we go. Okay, so I'm going to construct radius CO, and then I'm going to extend it a little bit. That's what we mean by it's produced. Okay, so radius CO, which has been produced. Cool, so we've done our construction. Then you can label those angles. You see that they're labeled there for you here because this is the memo. We've got C1 and C2 and O1 and O2. All right, so let's start. O1 is equal to C1 plus A. So let's find that. Yeah. This is O1. They're saying that angle is equal to C1 plus angle A. That's because O1 is the exterior angle of triangle, and it's actually quite good to label that triangle, of triangle AOC. Okay, so that's how we get that O1 is equal to C1 plus angle A. Then we have, but hang on a second, C1 is in fact equal to A. So C1 is equal to A. Because if you have a look at triangle COA, CO and OA are radii, which means that they are equal in length. Okay, so it means that guy and that guy are equal in length, which makes that an isosceles triangle. So C1 is equal to angle A. But remember what your reason is? Angles of radii, or angles of equal radii. Cool. Therefore, I can conclude that O1 is in fact 2 times C1, because instead of saying C1 plus A, I can now say C1 plus C1, because A is in fact C1. So we've got our first little conclusion there. Now, if you notice, they've got two triangles that are really similar looking. So I can say similarly. If I did the same stuff, so that's quite cool. In a proof, if I'm going to do all the same process but in a different triangle, I can just write similarly. I would get the same result in the other triangle, saying that O2 is equal to, so here, O2 is equal to 2 times C2. So I'd get the same results in the other triangle. Cool. Put that all together. Therefore, O1 plus O2, because actually ultimately I want this whole thing there, that whole angle, which is O1 plus O2. So I can say O1 plus O2 is equal to, here we know that O1 is 2C1 and O2 is 2C2. So O1 plus O2 is 2C1 plus 2C2, which you can then take that 2 out and write it like that. Therefore, angle AOB, that whole thing there, that one there, is equal to double that angle there. And that is precisely what we wanted to prove, so we are done.